So let's talk about approximation. So for binomial distribution, NP, this one means, well, this one means sometimes we need to calculate something like this. It's like, n minus x, and then this px, 1 minus px. Well, this is not really, what we're going to do here. This is on the week 3, page 17. That's a random variable and discrete variable, that slide. So what I'm saying is, if you want to calculate this one, it's really hard, right? So that's why we're not going to use this one. So that's where approximation comes from, because this distribution sometimes has a similar result, or it's kind of the same with normal distribution and Poisson distribution. That one is mu and sigma squared, and this one is lambda. So it's kind of like there are two ways we can replace this one. One is normal, one is Poisson distribution. So it's like there is a road and there is a split. So which one are you gonna go? Sometimes you go left, sometimes you go right, right? So here for this one, the rule is NP is greater than 5, or NQ, I mean Q is 1 minus P, right, is greater than 5. This is AND. So in this situation, the mu is equal to NP, and this one equal to NPQ. So here Q equal to 1 minus P. So if you want to go this way, you need to have this two condition met. If not, you need to have, like, there is another condition for this one. This is kind of weak. This needs to be N is great and P is small. I remember in one homework it's like 0.0025. That one P is really small. So in this situation, lambda equal to NP. Yeah, so there are two ways to approximate normal distribution. One is not to approximate binomial distribution. One is normal, one is Poisson distribution. And for if you want to go this way, NP got it greater than 5, sometimes 10. Let me explain this later. And NQ is got it greater or equal to 5 and 10. And if you want to go this way, N needs to be small and N needs to be large and P needs to be small. So let's talk about why NP is greater or equal to 5 or 10. So you might be kind of confused, like this is 5 or 10. Let me give you an example. So this is your test score. So this is 100. So this is 80. So let me ask you, what is good for you? Some might say, well, only 100 is good. 100 and 100 only is good. Some may say, well, if I got 90, this is good. If I got 95, this is good. If I got 80, this is good. So for different people, there are different definitions of good enough, right? So it's kind of situation here. If NP and NQ, they both greater or equal than 10, that's great. If it's just greater than 5, we'll say, well, you know what? Good enough. So if it's greater than 10, you gotta say, well, you know what? It's greater than 10. You're like, well, I got 100%. If it's greater than 5, you'll say, well, you know what? I got 95. I think it's good enough. So yeah, so that's why it's not like there is one number and one number only. There is kind of like a wiggle room. I do have other example to explain this problem. I'm not gonna say it on video. You can email me. So yeah.